Hello and welcome. This is Culture for Channels. My name is Alex, and in this video we are going to speak about inline functions. Inline is a compiler directive that tells the compiler that if it is possible, at every function call, at every call of this function, for example, we have this function max here, and where this function is called, instead of having a function call, the compiler should insert the function's body. This way, it is safe the function call, because what happens when a function, for example, I prepared this example project here. For example, we are in function main, and if we have here a function call, we have the function get max that gets two parameters and returns the max of them, and assign the result what function get max returns to variable max from main. What happens here is that when the processor, when it's executing the program, gets to this part here, to this instruction here, to this statement here, it will first pause the execution of the main function. It will go to the memory location when the function getMax is defined. It will execute the instruction of the functions from there, and after that it will return to function main. This pause, execute, and return takes a lot of time. It is possible that this function here to have very few instructions, and it is not necessary to do all this jump from one function to another. Let's take another example. In this example, we have this get var1. This is a function. I declare it as a inline function, and we'll go here and see that this function only has one statement. This return var1. var1 is a global variable, and in this statement here, we call this function get var1, and we assign the value underscore temp. Well, this function here, having very few instructions, it will lose a lot of time pausing the main function, jumping to the location when the instruction of this function is defined, execute it from there, and then returns. More probably, the jump from main function to get var1 function, it will take longer than executing the instructions of get var variable, of get var function. So declaring this as inline, the compiler will replace this function call after the compilation, not after the preprocessing. After the compilation, this is something that happens in the compilation phase, will replace with the instruction, with the function body of this function. I found these articles that are very interesting, and I will put them into the description. This is basically what inline functions are in C. You can read this to get more info about this. But there are some downsides of using inline functions. For example, it wastes this space, because let's say, for example, we have this function here, getMax, which is called 100 times in our program. What the compiler will do, it will replace its code to every function call. So it will replace the body of this function to every function call, and this will make for our program to increase, because we will not have a single copy somewhere in memory of this function, and when this function is called, the program will jump from the calling function to this function. It will execute it and then return back to the calling function, but it will create basically a copy of this function instructions every time this function is called. This is done in the compilation time, so the compiled program will already contain, to say that, all the 100, 1000 copies of this function, and this will make for our program to increase very, very much. Also in this article you will find others reasons why inline is not a very good practice. You will have here about C99 compiler, C99 standard, um, other variations of how to use inline or different forms about how you may found it, uh, especially in old programs. For example, here we have also the extern before the function declaration, and what this will do, it will not make this function anymore inline, because extern for compiler means that this function here can be called to say that, or it is defined in other files, and this will make our functions not be inline anymore. You could also find static world. This could be used in some programs to avoid different compiler errors, especially from the linker, or if the compiler doesn't have certain optimizations options set, you will have an error when using inline without static, because you will get a linker error. Um, this is also some explanation about using inline with GNU-C compiler. Well, what basically you have to do when you want to use inline, you will first need to read your compiler documentation, and you find a lot of this online. For example, this is for ZCC compiler, GNU-C compiler. You will find a lot of documentation about how to use inline here. For example, you have this line here, and I will explain it later in our test project. Also, you can read about, I will let these links in the description, about different optimizations that you can use on your compiler, and putting these optimization techniques in your compiler settings. You will also get different results. You may force compiler to do what you want to do. You'll find explanation for every optimization technique you find here. Usually in code blocks, this can be done in build options, and you have here other compiler options, and you basically put here all the compiler options you want, or the optimizations, or whatever you want. Save temps, for example, allowed you to see the intermediary files from the compilation process. So we have the preprocess file with .e, we have the assembler file .s. Definitely we have the C file. This is not a temporary one, and yeah, you have the object file. This is not temporary. I think this is kept, this is not deleted, and also you have the bin file. You also have a very good article here in Wikipedia. Um, Here is where I took is from where I took this this macros that allowed you to have a very good portability, because when you use a different compiler, different um, compiler directives may be needed to activate the inline, to force the compiler to make inline functions. You will also find it here that GNU-C compiler doesn't usually allow you to use inline, or it's up to him if he makes a functions to be inline or not. So um, as I did in my project, I took the that macros from Wikipedia and I put it here. So what we found here is that for different compilers, we define this macro, the force inline, to be as inline attribute and always inline. So if we put this inside of a function, in front of a function declaration, that function will definitely be inline. Let's see our test project. So we have this main function here, and I declared here some local variables, initialize them, and after that I have this variable max, which gets whatever get max return, the maximum of these two parameters. We also have var1, which gets the value of get var1. Here we have set var1, who set global variable, who set a value to variable 1, which is global. We have var2 temp, which gets the var2 from the we get the global variable var2 and assign its value to var2 temp. We have another set. We set the value of var2, of global variable var2 to 220, and after that we print them. Okay. First of all, these functions here are inline. Okay, so these functions here are inline. What this means? This means that the compiler will replace this function call here with the function body. So in this line of code, we will have max equal and these instructions here. Good. I know that this may be very not very clear to say that, but in order to make sure that my compiler will make this function here inline, and it will only copy its body to this line and will not make a function call. As I said, I had to look into the documentation, into the compiler's documentation, and see how to force the compiler to make a certain function inline. So this is what I had to do. Okay. Good. First, what I did was to write this program without having these functions inline. So I did not have force inline to any of these. So they were normal functions. And I compiled it, and I made copies of the C.E and .s files. And let's compare them. Okay. And as you see here, the only thing is that I do not have force int. Static can be used or cannot be used, whatever you want, whatever you decide. So as you see here, even if you use static or not, it will not make any difference. Sometimes when you don't have some compiler optimization, some compiler options, as I showed you before, you will have some linker errors if you don't use static. But I set them compiler optimization, so I don't have to use static anymore. But just for the idea, I left it here. So this is the code version with the inline functions are inline, and this is the code version which functions are not inline. As you see here, there is no function that has inline. Okay, and let's go to so in the preprocessed file .e files, we will not find any difference. We'll have the same differences as from here, because we have inline and not inline. Yeah. So not many differences to say that. Okay. Close the current tab. The main difference we will find in the assembler code. Okay, let's compare this. And first, the first thing you should notice is that this is the old one in which the functions weren't declared with inline. So what you will see is that these functions are not declared in memory as a separate function anymore. So they do not have a certain place in the compiled program in which they exist. Okay. But the main differences, you will find them here, I believe. No? Not here, I think here. Yeah, here. So as you see here, we have this function call set var1, call get var1, call get max. So this is basically um, this function called here. So get max, get var1, get var set var1, and in the version which doesn't have the inline before the function definitions, you will see that functions are treated as function calls, and if we have a function call. Here, when we have inline functions, we have the body of that functions. Put it here. Um, we should have get var2 in both of them, because as you see in our project, get var set var2 and get var2, they are not inline, so we should find them. We shall find their function calls. Well, I will actually search for their names. Yeah, you see here, they are both called in pretty the same places. They are declared. This is where they are called. Yeah, this is where they are called. And pretty much that's it. And pretty much that's it. Let's run the program. Okay, we have this. Good. So we have this print here, inline functions, and after that, max is equal to, well, because get max is an inline function, its call here will be replaced, as I said, with this statement, with this conditional operator. So if A is bigger than B, then it will return A, else it will return B. So this line of code here, this statement here, it will replace this function call here. So max will get the maximum between A and B, which is 20, definitely. Okay. Then the temporary var1 will get the value of of the global variable var1, yeah, which is 40, and after that it is print, and pretty much that's it. The same way the program is executed. As I said, I work in automotive industry, and in practice, to say that inline functions are only used for getters and setters in our projects. So these two examples here, set and get. This is what we usually use in practice. For get max, get min, we use macros, and well, to say that macros are more used when we have a certain logic, some bitwise logic, um, and inline functions are usually used for setters and getters of the global variables from that specific modules. Well, pretty much that's it. I hope you enjoyed. I will let the links to the articles in the descriptions and see you next time. Bye bye.